Hi everybody, this is section 10.2 from our Math to 11 Geometry textbook, and here we're going to look at areas of triangles and quadrilaterals and review perimeter. First we have our area congruence postulate, which once you read it, it makes sense. It says if two polygons are congruent, then their areas are the same, and we might use this in a proof, or again, it's common knowledge if two figures are the same or congruent, then they're exactly the same and they're going to have the same area. It's just a way to explain that. Next, we have our area addition postulate that we use when we're finding the area of a region that is not a single polygon. So the area of a region is the sum of its areas of its non-overlapping parts. So all the parts added together. And we will be taking a look at some composite figures where we find the area of two different parts and add them together later in this section. All right. The next few slides are just, again, a review of area, which we talked about in Chapter 2, so it's not any new information. The area of a square is, side squared, or again, you could do length times width. The area of a rectangle, we know it mainly as length times width, but they also call it base times height. And again, remember that height is connected to the base. Sometimes the height is called altitude. Next, we have a theorem for the area of a parallelogram. And since we're new to parallelograms, or we just introduced them in Chapter 6, a parallelogram, the formula is the same as a rectangle. It's base times height. Here, just know that the height is the perpendicular length from the side opposite the chosen base. And it has to be perpendicular, so it's often inside the parallelogram. Another formula we were reviewing is the area of a triangle. And then remember, the area of a triangle is half the product of its base and its corresponding height, or 1/2 base times height is probably how you're used to hearing it. Okay, so next we are going to be finding the area of these two parallelograms. And remember, the formula for the area of a parallelogram is area is equal to base times height. Your height is always a perpendicular segment from the opposite side, vertex on the opposite side to the base. So even though in this first parallelogram we have 3 values here, my perpendicular segment is 4 inches and it's connected to the 5 inches. So 5 is my base and 4 is my height. I don't need the 4.5 unless I'm going to find the perimeter, but they are only asking for the area. So if I do 5 times 4, it's going to give me 20 and its area, so it'll be inches squared. All right, for B, again, I need to locate the height and the base, and I do have 3 values here. But you're looking for that perpendicular segment. That's your height, and it's always going to be connected to the base. And even though this is a long line, here is my base. It's going to be the 2. So for this one, when I find my area, I'm going to do 2 times 3.5, and that is going to give me 7 centimeters squared for the area of that parallelogram. All right, so here we have to find the perimeter of the irregular room. And just a reminder, perimeter, we add up all the sides together. So right now I can start adding my sides together. I know I have 10 feet plus 15 plus 7, but then I'm missing a spot. I am missing the length of this segment here and this segment here. And this is where we can kind of use our properties of quadrilaterals to help us out. I am going to say, since this whole segment right here is 15, if I were to just extend this out, okay, it would be the same length as the 15 feet on the bottom. So because this is 9, that means that this segment right here, if I do 15 minus 9, is going to be 6. And then for the other one, the other segment right here, this little one, if this whole segment is 10, and if I were to extend this out, it would be like this whole segment. So if this is 7, that little piece right there should be 3, because 3 plus 7 would give me 10. So if I continue going around adding my numbers, I have 7, then I would have 6, and 3, and then 9. And I would add those all up together. So 10 plus 15 is 25. 25 plus 7 plus, I'm going to add 6 plus 3 plus 9 is 18. So 25 plus 7 will give me 32 plus 18. So that is going to make the perimeter of our room 50, and it will be feet, and it's perimeter, so it's just your units, not squared. All right, next we are going to find the area of an irregular room. And the best thing to do when you do this is to divide your figure, if it's a non-traditional shape, we call it a composite figure, divide it into shapes that we do know, sections where we can find our measurements. So what I'm going to do with this is, I can divide it in 2 places really. I could divide it here and find the area of this rectangle and this one. Or I could also divide it here and find the area of these 2 rectangles. Either way, we have 2 rectangles to find the area of. I'm going to leave it like this. So we'll call this rectangle 1 and this rectangle 2. So rectangle number 1. My dimensions, my length times my width, are going to be 8 times 4. So we have the dimensions for that. So I'll do 8 times 4 and get 32 feet squared. And then for my second one, for the second part, I need to, let's see, this is 5. So I have, let's say, the width, but the length, this whole thing is 12. But I need, from here to here. So if this whole thing is 12, I'm going to look to this top part up here. That's 4 feet. So that right here would be 4 feet. So that means in order to get this entire feet length of 12, I'm going to do 4 plus 8. So my other length would be 8. So 5 times 8 will be base times height. And that's going to give me 40 feet squared. Now to find the total area, you're going to use the area addition postulate, add those 2 areas together. So if I add 32 plus 40, it will give me 72 feet squared is the total area for the irregular room. One of the last 2 formulas that we're going to look at is the area of a trapezoid. And the area of a trapezoid is equal to 1/2 times the height times the sum of the 2 bases. So in here, they've labeled them so you can differentiate between the 2, base 1 and base 2, with the little 1 and 2 as a subscript to show that you're just differentiating between the 2 lengths. I've had students in the past to remember the formula. They say the area is 1/2 of a hamburger times bun 1 plus bun 2. If it helps you remember it, go for it. Your height in the trapezoid will always connect the 2 bases and be perpendicular to the 2 bases. So if you're not sure where the bases are or where the height is, look for that perpendicular symbol. All right, our next theorem is for the area of a rhombus or a kite. And this is the area to find the area of these 2 figures is a little bit different than finding like a rectangle or a square, because here we multiply the lengths of the diagonals and then divide by 2, or it's 1/2 the length of diagonal 1 times the length of diagonal 2 to find the area of a rhombus or a kite. All right, we're going to practice finding the area of a trapezoid. And if you recall, our formula for the area of a trapezoid is always going to be area is equal to 1/2 times height times base 1 plus base 2. Now we have a trapezoid here. It's the state of Nevada. So, our 309 here is what connects the two bases. It connects the 205 and the 511. So this is going to be our height, and this is going to be base 1 and base 2. So we'll plug those into our formula, and we have 1/2 times 309 times 205 plus 511. When we do the math there, and I add 205 plus 511, I did use a calculator, I'll confess. I shouldn't, but we get 716. And then when we do 1/2 times 309 and then times 716, we end up with the square, or the area of the state of Nevada to the nearest 100 square miles, because they did estimate the mileage a little bit, is going to be 110,622 miles squared, because it's area, so it'll be miles squared for the area of Nevada. Right, the last thing we're going to do is find the area of our kite. And if you recall, the area of a kite is going to be 1/2 times diagonal 1 times diagonal 2. So here, my two diagonals are given in pieces, so I'm going to have to add the 2 and the 5. That's going to be diagonal 1, it's going to be 7, and then the other one is 3, so times 6, and then times 1/2. So when I multiply, I'm going to do 7 times 6 first because it's easier. I know 7 times 6 is 42 times 1/2. So my total area is going to be 21 meters squared for the area of the kite. And that is it for 10.2 and all for Chapter 6 and 10.1 and 10.2 together.